Hi, and welcome to the Legacy Coderetreat codecast from nothing to system tests. During this codecast, I will show you how you can write the first system tests for a given legacy system that doesn't have any test. What we will do is we will have this codebase that is for a trivia game, and we will start writing some tests that are written in fact in a very black box style. So we won't touch any of the code, any of the production code, because we do not want to introduce defects. So let me show you briefly the code base. What we have here is a game runner that basically instantiates a game, adds a couple of players, well, 3 players, and then we'll roll the dice and decide if there is a winner. The game class instantiated here is this big class. What this code does is that it will generate some questions: pop, science, sports, and rock, and then each time someone answers correctly, they will have they will win a gold coin. So let's run the code and see what happens. It's compiling and we have an output. It's quite long and it says like that: chat was added, so this is the player name, and then they are player number 1. After that, there is a section on rolling dices and telling where is the location of each player, and what I'm interested in is what is going on at the end. So if I scroll down, I can see here that one of the players has won with 6 gold coins. So probably this is the win condition, to have 6 gold coins. So this is the game we have, and every time we deal with legacy code, we want to think about, in the first session, in the first part, how are we going to find out the outputs? We always want to focus on the outputs. So if I look at this code, I can see system out println a lot of times, and as I saw when I ran the code, it clearly stated that the output is the console. So practically this is the output of my system, and I'm happy because I can write some tests on this. So I have this test class already written here. It doesn't do anything else but telling me that JUnit works or not. So let me run it. It should fail, and it did. So if I will say assert true of true, it should pass. Let me run the tests again. Okay, so this shows me that JUnit is working good with this codebase. So let's try and write the first test, and what I usually want to do is to write the simplest test possible. So in my opinion, the simplest test possible would be to try to create an instance of the game class and then see what happens as the output. Of course, I do not know the output. This is what I want to find out by writing these tests. So the first test would be public void when game is created, something happens. I do not really know what happens, so we will see. I created a game, and somehow I need to steal the output of my system, and the output is in fact the console, right? So because I'm in Java, and you can do this in any language, I can basically get the system console rerouted to a stream. So what I need to do is to create a byte array output stream, and I need to create a print stream that would receive as a parameter in the constructor this byte array output stream. And now by magic I just say system out set out print stream, and in this moment I will have a stream of outputs here. So now what I want to say is, let's assert that something will be in the stream. I want my first test to be read as always. So if I run the test now, let's see what happens. So it says expected something but actual empty string. I can click here as well to see the differences. So in fact I have nothing here. If I run the test again, everything passes. So this is my first characterization test. This is how they are called because I write them for a system, and then I can characterize my system with these tests. So now I have my first test running. What I want to do is to refactor a bit, but of course first of all I will commit. So I'm saying that when a game is created, the output written is empty string. So let's refactor now. I do not need this test anymore. And also what I would like to do is have this extracted to a variable so that everything will look nicer. I want to have to show my reader of the code what I really want to do with this empty string, because empty string could be tricky. It could mean yes, I really did want an empty string, or it could mean that I just passed something there, and here it's clear that the expected value is really an empty string. So I will do this. I will say empty string is the stream that I want to have. I think basically that's it. I'm happy with that. So I will commit again, and I will say refactored the first test. Alright. So now let's look again at the output of my system when I run it. So if I run the system again, I want to look at the first parts of the output, and like this, step by step, to go on until all these uh, parts of the output are covered by tests. Um, so the first part is that a player is added, and when the player is added, I see his name here. So probably this will be the string that I'm waiting, right? So let's write the test again. When game is created, no, when player is added, his name is written. Basically, I need the same thing here to get the output from my console, and I will need again a game, and now what I want to do is to add a player, Adi, for example, and assert the fact that Adi was added is equal with the stream written to the console. Of course, I have a typo. Now, let's see what happens if I run the tests. So there are some differences. The first test is okay, but there are some differences. And it's not only that Adi was added, I should test also for this one. So you can see that my assumption was wrong. You can always have this problem when dealing with legacy code. So this is why you need to test your assumptions with writing these kinds of tests. So I will take this, I will copy it, and I will paste it here and run it again. Good. So my second test is running. What I want to do now is to commit, and I'll write that when a player is added, his name and his number are written to the output. Okay, of course I forgot to do something else here with this test. I need to write what it actually does, right? So when game is created, nothing is written to the output. The same here, I need to modify it because my assumption was that the name was written, so I need to add the fact that his name and player number is written. What I can do as well now to refactor is to extract this into a variable, which would be translated into let's say player name and number, and I can easily move this in the setup of my test. Okay, what is this? Well, I would like to extract this in a variable as well to make things explicit. So this is player name. Okay, and another thing I would refactor now is to have a better name for this test class. So I would rename this with a very appropriate name, game tests. Let's run them again and see what happens. So I have a very nice name now, and I have two green tests. Let's commit now. Refactored. Sorry, I would need to add as well because I renamed the file. So now I'm gonna say that I refactored the tests for the game class. Good. Now, what would be the next test to write? So I could try and add 2 players and let's see what happens. As you can see, I'm trying to make things a bit more complicated, but not very complicated, because often with legacy code it can happen that you can lose sight of things, and this is why I would like to have a test that is quite easy to understand now. I start understanding the system now because of these tests, so I can try and characterize the system. So what I would like to do is to say string player second player name Alex, and I would add another player. So here probably what should happen would be that I should have another sequence like this, right? But instead of Alex, instead of Adi, I will have Alex, and instead of their player number 1, I will have their player number 2. So if I am right, this test should pass directly. Let's see. If I run the tests, of course, I doubled the name of the test. So when 2 players are added, their name and player numbers are written. Okay, so I was right. This was the correct output of my system. Now let me commit and then we'll do a bit more refactoring. Added a test for game where 2 players are added and their names and numbers are written to the output. So now I can start seeing some duplication. I see that the game class is instantiated all over and over again here, and I don't like this because it is duplication, and I could make my tests a lot simpler and a lot harder to be annoying when I'll do a lot of modifications. So if now this constructor will change, I will need to change it in 3 places. What I can do now in order to avoid this is to create a before method, and I would add this instantiation in the before method, and I will make an instance. The instance I will as a variable. So now if I will delete this, all my tests should pass. Let's see what happens. Okay, so this was okay. Now, of course, I have this code that repeats again and again, and I don't like it because it's big and ugly and annoying. So, in fact, what this code does is that it steals the output of my console. So I could refactor this to a method which would be called something like get console output. So I detected that I have another two code fragments in this file that can be replaced. As I copy pasted from one to another, this is correct. So I would like to replace all the occurrences. So now I have a very nice method, independent. What I like to do is to put these private methods, helper methods, at the top, because after that I want to add tests at the bottom. So in this way I will have a very clear clear way of seeing and writing the tests. Now, what I could refactor even more, of course, let's see if the tests still pass. What I would like to refactor even more is to get rid of this line here. Basically, I would like to have this called always before the output, before the game is instantiated. And how I could do this is to have private string console output, call here get console output to string, and let's see if yep, it's still building. And if I would compare here to console output, and I would delete this, the code works. Let's see if I do this here again. No. So I have a problem. Why? Because I need to get the output before this part of the code. So I cannot really do this here. So I will be happy to just leave the code as it was and just have this first row of code with calling the get console output method. Let's see if it works. Okay. So I wanted to do this to show you because in order to steal the output of the console, you need to call this always before the console is called in the code, in the production code. This is very important because if you'd do this afterwards, after game add, for example, you might have issues of not seeing any output, and you might think that there's a problem in your testing code, and it would be the fact that you don't call it this at the beginning. So let's commit again. Refactored game tests. Good. So this is the way to continue. I have the players, and the same thing happens here, adding the third player, but then some other things happen. So what I can do now is try to go on with another public method from this game class. As you can see, my ID tells me that the method displayable is not used, which is very interesting. Again, we have legacy code, but it is public. So if you'd have this method public and you'd have an API used by other systems, I don't know, maybe you'd like to delete it, maybe not, but you need to check this out if this is used by some other legacy systems as well, and I wouldn't delete it anyway at this moment. So what we did is we tested this method add. As you can see, we tested it without even looking at it. So with legacy code, it's not important to read the code, the production code. Important is to just find the outputs and then find out how you can steal them in order to characterize your system. Now there are other methods around here that we can test. For example, roll. For example, ask questions, and so on. So I will write another test for roll, and then I will let you go on with this activity back home. So let's write another test. When rolling dice, something happens. I don't really know what happens. So I have already a game. Let's say I roll it with a 1, and of course I need to get the output of the console, and I will assert that, of course, empty string equals with the output. Let's see what happens if I run the tests. If I run the tests, not the production code. Okay. So something's wrong here. Let's see. Index out of bounds. Very interesting, right? So we have an error. We should understand what happens here, because we don't really get this. It happens at game Java 55. In fact, what the code does is calling these players, but these players is an array list, and when it starts trying to get the current player, it doesn't have anything. So I have an index out of bounds exception. Probably this means that I need also to add a player to the game before rolling a dice. So I will add some player and try to run again the tests. Now the call works, but I have this output of the system. So if I will paste it here, and if I will run the tests again, the codes pass. As you can see, I start having duplication in this part of the output. I would want to address this issue sometime after, in the future, after I will build these tests, these system tests, as a safety net for my future refactorings. So the things that are added in this test are these 5 lines of code, lines of output. It says that some player is the current player. They have rolled a 1, so this one is clearly related to the one I wrote here. Some player's new location is 1, so probably this one is also related with the dice that I gave them. The category is science question 0. Let's see if we run again the tests. So they still pass. Why did I do that? Because sometimes you might have random outputs. So you might want to be sure that even if you kept the output of the system, you put it as an expected value, next time you will have the same value as output of the system. Sometimes maybe here we won't have science, but we would have music or rock or whatever. So this is very important to check. Of course, I'm not happy that I have this duplication between the outputs, this and this, and this shows me that my system tests are brittle. So if something would happen to this text, for example, instead of was added, I will say some player has just been added. I would need to change all these tests, and all of them, well, excepting the first one, will fail. So this shows me that I do not have unit tests. I have some system tests who are checking for my module as a black box. So to wrap up this video, let's start over and recap a bit. What we've done is we've looked at these outputs of the system. We saw that some players are added. This is what happens in the first place. We looked a bit at the code, and we understood that we need to create a game instance, and then we need to create to add a player, and we took the output of the system by hijacking the console, which is the only output of this system. Of course, with your systems you might want to understand which is your output and try to hijack that as well. There are several techniques, but having this system in place here with the console, this is the simplest one for my case. So after that, what we've done is that we wrote some tests and we started understanding the system. We started understanding that we have some players added, and in that moment we have some text written as output. When we add 2 players is the same thing, and then when we add some player and we roll a dice, we will have this output added to the prior behavior. So this is the first stage of checking how a system works from outside, and I will show you now, before we before I leave, I will show you how useful these tests are. So let's see if I'll add here a space and I'll run the tests again. The test on the production code, right? I will have some failing tests. Of course, excepting the first one who doesn't really check this part. The problem is that I have 3 failing tests, but the good thing is that I have a way of seeing if I will do small mistakes like this when changing the code. And this is what I want to have when I deal with legacy code. First of all, some very simple tests. So that was all for today. I will continue further with some other system tests. So until then, have fun coding.